So yesterday we checked a number of functions that are used in that is just getting the general overview of your data set. We checked how you can read your data set. That is from a CSV file. How you can convert that data into data frame that is easy to work with. We also checked how you can change dictionary data into a data frame. So I think also we just had an overview of that is the describe function. We check the head function, we check the tail function. We also check the info function. And also I think we checked how you could deal with null values in your data set, and even how to check if you have uh, null values in your data set. So I think we checked a couple of ways in which you can deal with those null values, or what we call the empty cells. That is now in data cleaning. And I think someone just requested if we could maybe look at the fill now method and the drop now method. So I would like maybe to start from that, and then after that maybe we can go through the we can get to go through the EDA process. We see how it works, what you do in the EDA process, and then maybe we can proceed to the other part of our discussion. So I would like to start with the fill now method. I think we can start with the drop now function before we get into the fill now method. So we said that the drop now method will help you to drop all the null values in your data set. And I think I demonstrated that. So I think I can just upload these. Let me just try to upload the data set that I was using yesterday. I think I can just upload it here. You can as well as load the data set. I think I shared with you in the WhatsApp. So let me just upload that very fast. I think now that I think it was data on exercises. So let me load that. Yes, I think we have it. So let's start by reading this data set. Let's try to. Okay, we said the first step is to import pandas as PD. I think I can go through this process very fast, and then we say that df is equals to that is the PD dot read. This is a CSV file. So as I showed you how you can copy the path. Just have to put your cursor on the data set that you want to read the path. So you see the three dots, you just copy the path. And that path is the one that you should place inside these two opening and closing speech marks. So then after that, we see the next step is to convert this into a data frame. So we can just have the df is equals to this is the PD now dot data frame, and then we pass our data set. So with this, we should be able to get the data frame. And I think you can just check if you we have it by using the head method. And I think we already have our data set in place. So we said we start with the drop now function. So I think you can just, let's try to read this, the first 60 rows of data in this data set, so that we can see where we have null values. And we can see that in this exercise data set, in the date column here, we have a number of null values. We have a data that is a data at point that is at row 6. We have a null value also in 14. I think we are just focusing on this column here. That is the date column. And also you can see that at 14 also we have a null value. So these are the kind of null values that maybe you can use the drop now method to drop them. But I said that you should be very careful when using the drop now function, because we said I was explaining a case where you have just a small data set, a small data set, and if you have a lot of maybe null values, if you just happen to use the drop now, you notice that even your data set will reduce. So and that one could easily maybe cause could affect could cause could maybe an could cause that one could affect your results basically, because we said that if at all now you are doing analysis on a data set, and then maybe you happen to reduce the size of your data set, maybe by using the drop now function, you notice that you could get you could that one could affect your result. So we said uh, that if you have a small data set, maybe you can check other ways of filling those null values. Because we said that if you use drop now method, let's say like in this column 6, if you just happen to use the drop now method, it will drop the rest of the data in other columns. So if we just maybe, let's say we were using the drop now method, it will drop all these row. And you notice that at the other columns we have the data set for that row. So meaning that if you have a small data set, you better find other ways of filling these null values. So let's see how you can use uh, the drop na function to drop the null values in this data set. So I think I can just have hash using drop now. This is method, yeah, method to drop all the null values. He said it's very easy because you're just going to call or invoke your data frame, which is df, and then you just have like to call the method now, which is the drop now. And then you said it takes just one parameter, that is the in place parameter, and you set it to true. So I think we can do that very fast. That is a df.drop. You already have it here. Let's see what happens when we run this. So if maybe you were to check now, that is the df.head. and let's check the first 60 columns. Let's see what happens. Let's see what happened. You notice that initially we had row number 6 with the data, and also we had row number 14 with data. It's only that we don't have values for the date column. But now, if after now using the drop method, you notice that we don't have the row number 6. And also, if you are to check carefully, also you don't have row number 14, meaning that we have dropped all those null values, and that one will apply in cases where we have null values all through our data set. So that is how we use the drop now. But you should be careful, especially if you have small data sets. You can also check at line 56. We don't have line 56 in this one, simply because we had another null value here. That is at 56. That is the second column. We have a null value, and also at column dates we have a null value. So that is how drop null values method works. So I think after that, now we checked how you can, instead of dropping all those null values, we were checking the ways you can use to fill those null values. And the first method that I used was to use a random value, whereby I was maybe like, I don't know if I can locate that code somewhere in these, whereby I just was it what I use 100 to replace. Let me see this. Even you can just use this one for date, whereby I used the fill now method to to replace all the null values in the date column with just a random date. Uh, so that is just one way of dealing with the null values. Because if I remember very well, we also checked how you can fill those null values using let's say mean, mode, or even median of a certain column. And I think this is why you are using the mean for the duration column to fill all the null values. I think it was quite simple. Like in this case, we were just calculating the mean. And I noticed that we have methods of calculating the mean, right? Which is very easy. You just have like to say to assign, okay, this is the variable name that we are using, the mean of our DF is equals to the DF, and then we specify the column that you want to find the mean for. In this case, it was duration. Then after that, we just have to invoke or call the method mean, and then we should be able to calculate the mean of this column now. Then after that, we said we go ahead and now replace all the null values with the mean. So that fill now method will always take two parameters. That is the mean value and the in place parameter, which we are setting it to true. So if you can just let me just try to demonstrate this once again here very fast, so that you guys you can see that this um, has this. We just try to locate that code. I think it's this. Is it this one? Let me see. Yes, I think it's this one. So below this, let's have another. I think you can just use this here, and we can see that fill in null values using main. And I think you can just copy paste that. So before even we get to this, I think I can just comment out this and try to find the mean for try to find the mean for this column, that is the duration. So we can have mean. Uh, we said that you can either use the print or just type the variable name here. So you notice that the mean value for this is 59.7.705 and other decimal places. So we said that now we can use in cases where we have null values in this duration column. We can use the mean value now to we can use the mean value to replace all the null values in that case. So let's do that very fast. I think I can just run this again. Then let's see. Let's replace this. So this is the code that I'm using to replace with. That is the df, and then we specify the duration column, and then dot fill num method, and then we just pass our mean here, which is our mean underscore df, and then in place true. Then let's try to type the new df here. I think you can just use the df dot head 60. So, but before we do that, let's just maybe check just one instance where we have a null value in this duration column. And I think, was it at line 50? Okay, let's check this. It should be this one. Yes, you can see that at line 50, at line 51, we have a null value. And also at line 56, we have a null value. So we are going to, after we replace these null values with a mean, we are going to check if it was successful. So let's try and run this. And I think now we can just check line 51. Where is that? Line 51. That is line 51 and line 56. You can see that we have replaced that with the mean for this column. That is basically how we use the fill now method to fill the null values. So to the bidder, are we together up to that point?
Yeah, I'm grateful.
Yeah, I think that is it. Okay, thumbs up for the rest if you are together. Good. So I think that's all with the null the filling null values with the mean. And also you can at your own free time you can try using the mode, and even try using the median. Try filling that with the median. So I think that is it with that. I think you can just check how we are using the mode here. This is how we calculate the mode. We have the function for calculating the mode. You just have like to specify the column that you want to find the mode for, then the dot mode function, and even you can also add that is the index, just to mean the first, in a column. You can maybe have to you can have maybe, let's say we say that mode is the most repeated number in a certain sequence, right? So let's say maybe if you have a column with maybe maybe two. You have two instances where maybe the number of repetition of those numbers is equal. So we always take the first, and that is why we are in the mode section. We are saying that we are identifying the we also including the index, that is. So you can also try this at your own free time. So yeah, that is it. So let's get into the cleaning data of wrong format. And we said that okay, who can tell us what is a wrong format? Wrong format in a data set. Maybe someone can describe for us uh, or what do you guys understand by wrong format in a data set? Maybe someone can just tell us what he or she understands by wrong format. So someone to volunteer. No one? To say without what do you understand by wrong format in a data set? No one is willing to tell us. Sylvia?
I'm thinking about it. Just a minute.
Okay. Yeah, I think in most cases wrong formats in most cases most comes with in most cases it always or in most cases it happens with the date columns because you might find let's say maybe you have a date with a wrong format, and now you always have to maybe change that to the right format. So let's say maybe we have of course we know that let's say we always know we know that Nia has 12 months. Maybe you can see somewhere we have maybe someone maybe during the recording he wrote maybe 20th, and then akaeka maybe let's say instead of maybe putting 12 to indicate that it is December, maybe he had maybe 30, it's 13. And you notice that we don't have a month that is 13. So that one can be simply be said to be a wrong format, and you can change that. You can change that. Maybe let's say maybe you have a day that is 32, and you know that also days the highest date you can have is it that one. Let's say maybe you had a 32. That one again is it's a wrong format. Um, those are some of the things that maybe you can change in your data set because we have the functions that will help you to do that. So let's see. Let me just give a case here. I think I had a case where we had wrong format. Where is this? Let's see these. Let's see our data here. I think we can just use these. Let's see this. I think I should upload the other data set here. Let me just upload this data set that is called data. Let me upload this and see what we have. Good. Let me just try to read this data set very fast. I think I can do that with this code. So we start by importing pandas. We have a df read csv file. Maybe what I should change here is the data path. Before I change anything, let me just try to see what we have in this data set. Df is equals to df dot. Oops, I think I'm getting an error here. I don't think it's this data set because I think with this one we don't have the date column. Let me check this. Let's see what we have. Oops. Let me just check this. Just a minute. But also I think we can just try to check this one. Let me see this. I can just explain without this. So let's use the still let us just use the exercise underscore data. You can just demonstrate using this one. And I think I have an error here. Oops. Let's go to the second step, convert this to data frame. You can have df is equals to pd dot data frame. You already have it. So df I think you can just pick the first 5 rows. So with this one, with these dates, you notice that we have the proper dates here, right? But let's say we have an instance where we had a date like this one. So let's say maybe we have an instance where we have a date like this, a date enclosed in these opening end and closing speech marks. So this one now happens that this one is no longer a date, but this one is now a string. This one is now a string, right? This one is a string. I think you can just comment it out. So this one is a string. So we need we need to convert this one to we need to convert this one back to back to date format. And that is why I'm saying that you can have a data maybe in one of the column that is in the wrong format. Like this one, we cannot treat this one as a date. Let's say maybe we just had an instance in this column that we had this one that is on 10th May 2022 as a date, but now enclosed in this quotation. So this one now changes from date to a string. So we must find a way of now converting now this one back to date, and that is just one instance of having data in the wrong format. With this one, we have a number of ways you can convert this one back to. We can convert this one back to date. This one is easy because we can just strip the that is the quotations. That is the opening and closing quotation. But also we can have, let's say we have a date like the one I was just saying, this one. Let's have a date where maybe we are starting with 13th 2023. Now you notice that this one is it's written as a date, but you notice that in the month part we have 13, and then we don't have a month with the number 13. So it must maybe be either it was maybe a typo or maybe something of the sort. So again, now this one we must find a way, or we must find a way of correcting this. And that is why we say that you can either choose to Maybe you have a large data set. Maybe you can, instead of having that hassle to convert this back to converting this one back to date, or even converting this back to date, you can either choose to drop such column. But let's say in cases where you have a small data set, then you can find a way of maybe with this one you can strip these. I think you are going to see how you can strip this quotation, and we also with in this case we can find a way of replacing these with we can replace these with a good date. Maybe you can change this one to 12 or maybe 11, or a number that it is valid for a month. So I think that that's all about what that's all about that's all about uh, like correcting wrong data formats in a data set. But also think of maybe you are correcting heights of people, maybe a group of people, and then that you notice that maybe you are correcting a group, you are correcting height of a group of people, maybe let's say 10, or maybe we can even use to 20. And then maybe you happen to find, let's say we have a list here. We have a list of heights. Maybe we can have something like let's have we can have it's a human data. This one, we have something like, let's say we have something like now height in a list. Let's put this one into quotations, and then we have a list of heights. Let's say maybe 4.5. We have 5.6. We can have a person with maybe 6 feet, and also maybe we can have someone with 7 feet. But let's say you find a value that is 45. Let's say we are correcting these heights in feet. So you notice that there is no person with 45 feet who is 45 feet. So meaning that this might be maybe a typo. Maybe it was supposed to be 4.5, or maybe 4 and then comma 5. Again, you notice that this one here, it's a wrong data. It's a wrong data. In cases now you are correcting height. So again, with this one, you can just maybe you can just remove this. You can just remove this, or maybe convert this one to, you put a decimal place, maybe 4.5, or maybe, I think the best way is even to remove it, because you can't know whether it was 4 or 5, or maybe it was 4.5. So in this case, you just have to remove this. So these are the cases uh, that you can get in your data sets. So it's upon you now to be keen when you are dealing with this data set, especially now when it comes to data cleaning. So let's see, with the dates. With the dates, we have a function again that is called the to date time. So let's say maybe you have a list of strings like the one we had a date with. Let me show you that again. A date with let's say it's a string. Let's say maybe it's 12. 12, that is 2023. you can always convert this one to a date using these using this date to date time. And then you just have to pass the value. That is, let's say you have a whole column with strings. You can just pass uh, the name of the column. In this case, I think with this data set that I can't locate, it was in the date column. So you can always convert this one using the to date to underscore date time function. So there are a number of functions again. I think I'll share with you the documentation for the pandas, so that at least now you can go through these functions that we have that are available for you to even change those formats. So we go ahead and say that let's check, let's see another instance of a wrong data. And we are saying that wrong data does not have to be empty cells or maybe the wrong formats as we have checked. It can just be a wrong, it can just be wrong. Like let's say, like the case I was just saying that if someone registered 199 instead of 1.99, right? That one can, in that case, that one can be a wrong, can be a wrong data. So we go ahead and say that sometimes you can spot wrong data by looking at the data set because you have an expectation of what it should be. Like the case I was just saying about the heights of people. And then you just spot, let's say you are recording those heights in feet. And then you just find there is a height that is 45 feet. So in a normal case, you don't expect someone to be to have that height. So in that case also 45 can be a wrong data. So we are saying that if you take a long if you take a look at and I don't think we have that data set at the moment. So I think that one is just irrelevant in this case. So let's see the replacing values, and we are saying that I think we check these, and we say that one way to fix long values is to replace them with something else. And we said that something else can be a random number. You can either use a mean, or maybe you can use a mode, or maybe median, depending on the kind of data you are dealing with. Again, there is that attribute that we called lock, that would help us to locate a specific data in a row. I think you can remember that. That one will help you now to fix those kind of errors in your data, or those typos in your data set. So it's upon you now to remind yourself on how you are using the lock attribute in data frames to locate that specific data point, and you change it accordingly. So, and even you can see, like in this case where we are saying that let's say maybe you had a duration of 45 in a row 7, and you want to change you want to maybe let's say you want to set a duration to 45 in the row number 7. That is the duration column. It's just easy. You just have to use the df.log. You state the row that you want to change the data for. That is row number 7, and then you specify the column, and then you set the data type. I think we had an example on this, so you shouldn't be asking where we use lock. So I think that's all with replacing those values with the appropriate values. And now from there, I think you can just get into, we can get into, I think we also checked these, removing the rows. I think we checked these. maybe something that I haven't mentioned in the pandas is removing duplicates. And we said that in a data set, I think yesterday we said that in a data set you can have duplicates. And we say that duplicates rows are rows that have been registered more than one time. That is a row maybe appearing twice with the same data. Uh, with how you can maybe let's say how you can maybe check if you have duplicate in the data set. We have a function that is called duplicated method that is used to uh, this duplicated function returns boolean values. That is, let's say maybe if you have a duplicate, it will return a true, and if you don't have a duplicate, it will always return false. So let's see how uh, we can we can check the duplicate using the duplicated function. And this one is an easy function. Let's just have a check on this data set if you have duplicate values. We just have like to have a df dot. I think it's always good to comment out these check in duplicated values. That is in data set. So we can have a df dot duplicated. With this one, it will where we have if I was maybe to run this, if I was to run this, I'll get along these. Let me show you. Uh, it will just check if we have duplicates in all these rows. And if we have a duplicate, it will return a false. It will return a true. Let me just run this and see what we have. We can just try to run through this. Let's see what will be the output here. In this case, I think I can just comment out this. Let's run this. I think we have an error here. What am I told? Let's see this. This one should be a function, by the way. That's why we are not getting the output. And now you can see, maybe I can just use even the head dot head. Let me just check the first 20 rows of data. And now you can see that I'm getting a list of true, false values. So in cases where we have false, it means that that row has not been repeated in our data set. And where we have a true, it means that we have that row of data repeated. Like you can see, we have row number 8. It's duplicated. We have row number 9. It's duplicated. We have which else row do we? Okay, I think we have up to 20. We just have two rows that are duplicated. So we have a solution to the duplicated values. We say that the solution to duplicated values is to remove them, right? So, and the way we remove the duplicated values is that we have another function that is called the drop underscore duplicated drop underscore duplicates. With this function, we'll be able to drop all the duplicated values. We said that pandas is reaching these methods, so meaning that you don't have hassles to write codes to remove this duplicated. Again, you can see this one is simplified by this function. Maybe you can just try to drop this and see what we get. It's just very easy. You just have to have df and then dot drop underscore duplicates, and then with this function it will just take one parameter. I think we said these are what we are calling the parameters. And then maybe if now we try to run these, we should not get duplicates values. Let's see. I think after dropping, I should get the head of maybe the first 20. Let's take the first 20. Let me just try to comment out these. Oops. I think I'm told that this one has no attribute called head. I think you can just drop this one and assign this one to new underscore data without duplicates. So I think now with the new, we can just have dot. Let's have the head. We take the first 20. Let's run this and see what we get. Oops, again. Let me check this. Or maybe we can just drop these. Let me just try to print this df. And see if we have duplicates. And now you can see that from that is 0 to 21 now, because I think we just dropped one. We just dropped one duplicate. So meaning that there will be an addition of a row because you are checking the first. That is the first 20 rows, meaning that in this case now we don't have a duplicate. In fact, in the first case we had, let me check this. Is it try 9 and 10? We had duplicates. Let me just try to confirm that. I think row number 8, is it? Yeah, it was row number 8 and 9. So with this now we have duplicates here. So it means maybe line 8 is repeated to line 9. So when now we use these, let me show you. When you use these drop underscore duplicates in place true, it means that you are going to drop one of the line. That is either 8 or 9. And that is why we are getting these. I think we have dropped. I think both of the lines they were repeated. So and that is why we are dropping line 8 and 9. So meaning that they were duplicates. So that is how we use the that is how we drop the duplicates in your data from your data set. I don't know if there is any question up to that point. Any question? Okay, thumbs up if you are together. I can see Sylvia, we have Tuzebida, Amos. You can see most of us are we are together. What about Megan? Megan, are you able to follow? I think if you are not in position to unmute, you can just maybe write something. I think Megan is, I don't know what has just happened. Mombi, are you able to follow? Yeah, I can see Mombi is able to follow. So that is how we deal with the duplicated values in your data set. So I think that's all about the functions that we have to clean your data set. Yeah, and I think this is something that we should maybe have covered yesterday, but now it's done. So if no questions, I think we can just proceed to lecture number 6. We can just proceed to lecture number 6 if no question. Yeah, let's proceed to lecture number 6 if no question. So I would like us I would like to introduce new library that is now after pandas. We have another library that is called NumPy. NumPy just means numbers Python. That is, I think, numbers in Python. So basically, Python it's very slow in processing data, in processing that is numerical values, and that is why we have NumPy library in place. So with NumPy will help Python to speed up in the way it deals with numerical values. Because again, in data analysis, you notice that we are dealing with numerical values. So NumPy now will help Python to to work with these numerical values, and that is why we are saying that um, that is why we are saying that with NumPy with NumPy you are able to deal with numbers such as the arrays. You notice that we have large arrays of numerical data. You can have uh, the linear algebra functions. Also, NumPy will help us with dealing with matrices. So and that is now we have the NumPy library in place. So basically, it's just a library that helps Python to deal with numerical values. And the numerical values, arrays of numerical values. You can also have arrays of matrices. We can have the algebraic equations. So this is the library that will help us to work with that. And as you can see that you are saying that NumPy just start for the numerical Python. Just as we saw that for you to use NumPy, you must install that. That is for those who are using the VS Code. I think there are also people who are using Anaconda and the PyCharm. You must install it in your local machine. And we see that we use a package management tool that is called pip to do the installation. But for Colab, again, it is pre-installed. So again, you don't have to do the installation. So if you're using the VS Code, PyCharm, or Anaconda, you just have to use the pip install NumPy as you guys used this pip to install the pandas. So you can do that as well. Then after installing that, the first step is always now to import that NumPy that is in your working file. So like in this case, we are going to see how we import NumPy. And again, it has a arrays. Arrays is we import NumPy as np, just as we had an arrays in pandas. We import pandas as pd. So again, with NumPy, you just have to import it as NumPy as np. Um, I think they're quite similar in how we install them and how we import them. So you can just import that. Um, so we are going to start with simple arrays. We are going to start with just simple arrays, and then we see how we can convert them to what we call the ND arrays. Uh, okay, maybe to start with, let's have someone giving us a. I think I showed you how you can create an array. So let me have someone help us to create an array of numbers. You can have an array of 10 numbers. And then we see how you can use NumPy to convert them to ND arrays. So let's have just someone to volunteer and give us an array of 10 items. In fact, we can have 10 numerical numbers. So can I have someone to help us create that? I think I can just open a new cell here. Let me just have a cell here. Oops. Yeah. So let's have someone. Can we have Sylvia? Sylvia, how are we creating arrays in Python? Let me just try to hide those codes. So let me have someone. Sylvia, can you help us to create a numerical array of 10 numbers? You can unmute your mic and tell us what you are going to do. Sylvia, if you're in a position, you can maybe type in the in-call messages if you're not in position to talk. Well, maybe let's have Amos. Amos, are you in position to talk? You can help us create an array of 10 numbers.
Through presentation of my screen, or
No, I think you can just explain how you are going to do it. I'll help you to do it here.
I you can type array.
Sorry?
You you can type array
Yes, array.
and then an equal sign. Then use the square brackets, open square bracket.
Okay, so the square brackets. Good. I think this is even the syntax that I was looking for. Was yeah, this is the syntax that I was looking for. Because after this, you just have like to have the 10 numbers, right? So we said different data structures, we create them in a different way, right? And with array, we use the square bracket, or use a constructor function if there is any. So I think you can just have now 10 numbers. You can just have 10 random numbers. Let me have. Thank you, Amos. This is the syntax that I was looking for. And then let's have just 10 random numbers. Let's have, we can have 7, 8, 8, 9, 8, 5. You can have 7, 8 again. So how many are these? That is 2, 4, 6, 8. We can have, so this is an array. I think you can just call it numerical array. So this is an array of 10 numbers. And now we can use what you are calling here numpy to convert this one to an end we call it to an nd object. And we are going to see that shortly. And maybe someone might be asking, okay, why are we converting these? Why are we converting these numbers into? Why are we converting these numbers into? Why are we converting these numbers into arrays? Maybe that is a question that is ringing into your mind right now. So again, with NumPy, we access functions that resides in this NumPy that will help us work with numerical values. just as in Pandas, that we were able to access so many functions that help us to work with data sets. Uh, Also in NumPy, we are going to be able to access so many functions that will again help us to work with numbers in Python. We are going to see how you uh, we can convert. Maybe we are going to see the types of arrays that we have. That is the one-dimensional array, two-dimensional array, three-dimensional arrays. How we can convert maybe one-dimensional array to two-dimensional array, two-dimensional array to three-dimensional array. So we are going to see how we are able to use the functions that are in NumPy to do that. And we said to start with, we always start with the import NumPy, and then we just have to we can have our array. Let's say like in this case we just have array is equals to let's see this. Let's use the one that we had here. uh, it's just right below here. So this one, to convert this one into convert this to nd array, that is in Python. Oops. This one to be a comment. So it's always easy. We can have it as a array now. We always start with the import numpy as np, and then we have the numerical array, and then we just have to pass our. I think you can just let's start with the import numpy as np. That is now the first step, and then we have to use the np dot array now to convert this one to convert now this one to an nd array in Python. Then after this, what do we do with this? This is how we convert this. That is np dot array, and then we just pass our array here. Maybe we can just maybe assign this one to something like nd underscore array is equals to this, and even maybe we can try to print this and see what we have by running this. So I think we are likely to get an error because of indentation. Let's see the I think we have an error because of that white space between nd and underscore. So I think you can just run this, and now we should be able to see our nd object. Now this one is already converted. It's already converted to just from a normal array to an nd object using the NumPy library. So that is how you convert just a normal array to an nd array. But also there is options of creating. You can just pass these values here. Let me just show you this. You can just copy these. Let me show you. You can just copy these and now pass these as a parameter here. It's just the same. It's just the same. You're going to get the same output. You can either define these in a different variable, or maybe you can just pass it during the conversion here of during the converting of normal array to ND array. You just pass the values here as a list. This is going to get the same. You're going to get the same output. So basically, that is how we do that is how we create an ND array from a normal array. So I don't know if there is any question regarding that. Any question? So I think we have checked how you can create that ND array. So let's move to the next part, which is always now the dimensions in arrays. I think you can just go through the dimensions in array. Then I think we are going to proceed from that tomorrow. And we are saying that a dimension in array is one level of array depth. We always say that this one is the nested arrays. And the nested arrays are arrays within arrays. We have we start from zero D arrays. D is just to mean the dimension. Moving up to, you can have up to 5-dimensional array, 6-dimensional array, but we always start with the 0-dimensional array. And the 0-dimensional arrays, they are called scalar values. I think you guys know about the scalar values, the scalar and the vector values. I think you must be familiar with that. So any number like 45, is just a zero. It's just a zero dimensional array, or what you are calling a scalar value. I think we have an example here where we are saying that create a 0D array with a value 42. So you just have to have the import number as NP, then the name of that 0D array, which I'm just calling. Like you can just change this one to a more meaningful word. That is array is equals to NP, which is our number here, and then we invoke the function array, and then we just pass this scalar value. It's just that easy how you can create a 0D array. So from the 0D array, we have one-dimensional array, and with one-dimensional arrays, now we have a number of elements. We have a number of elements. Instead of just having one scalar value, we have now a number of values. Maybe we can have 1 to 5. So when you are told to create an ND array of one-dimensional, that is one dimension, you can just have a list of values. That is one. You can have 1 to 5, or maybe the numbers of your choice. You put them in a list, and then you just have to convert that one using the np.array. You pass the values. I think we just had like this one, the example that Amos gave us. Um, that is a one dimension. That is one-dimensional array. So let's see the two-dimensional array. And we are saying that an array that has one dimension arrays as its element is called to 2D array. So I don't know if that is clear. We are saying that an array that has one-dimensional array as its elements is called a dimension. It's called a 2D dimensional array. So meaning that we can have an array here. This one is now. Let's have this as a one-dimensional array. Let's have that is the first. Let's have the second dimensional. The second. This is the second what? This is the second one-dimensional array here. Good. I think you can have some values again. We can have 14, 45, and something like 67. And even maybe we can have the third single dimensional array is 0, 4, 2, comma, let's say 8, 9. So now when we take all these single dimensional or one dimensional array into one array, now like this one, maybe we can have now combined underscore single arrays. Oops. Single underscore arrays. And now we have something like this. I think you can just pick all these. We just copy them here. And what I'll just remove is this naming. And now you notice that uh, these combined single arrays, they are forming now something that we call two-dimensional arrays. That is what we were saying here, that an array that has one-dimensional arrays as its element is called a two-dimensional arrays. You can see here that we have single 1D arrays as elements of the combined single arrays. Now this one is a two-dimension. This one is a two-dimension. This one is a two-dimensional arrays. So you can proceed to now three-dimensional arrays. And now you are going to see that an array that has two-dimensional arrays as its element is called a three-dimensional arrays. So meaning that a three-dimensional arrays will have let's see what is the definition of this. We are saying that an array that has two-dimensional arrays as its element is called a 3D arrays. And now we are going to proceed like that. For four-dimensional arrays, we are going to have 3D arrays, 3D elements as its elements. So and then we proceed. If we want to have a five-dimensional arrays, the elements for five-dimensional arrays is it's the four-dimensional arrays elements. So I think that is it with the dimensions. The dimensions in arrays. I don't know if there is any question about the dimensions of arrays. Maybe someone can ask a question on that. I don't know if there is any, but basically that is the dimensions. That is how the dimensions of arrays are defined. So for zero-dimensional array, scalar value. For one-dimensional array, a list of scalar values. Two-dimensional arrays, Um, we have one-dimensional elements as its element. Then we proceed to two-dimension, three-dimension, four-dimension. You can have up to dimensions of your choice. So, any question? And we are saying that an array can have any number of dimensions. I think I've already saying that. We are going to see how you can we can use the something we call nd min to create the dimensions of our choice. So I think that's all about the dimensions. I don't want to proceed. I don't want to proceed from that. Uh, so I'm just waiting for any question regarding that, and then maybe from tomorrow we check. We are going to check NumPy array indexing moving forward. Any question?